Morning. So we're going to finish up section 4.5 today, which is applying properties of logarithms. Yesterday we talked about the product property, the quotient property, and the power property, as well as expanding and condensing these logarithms using it. So you may have noticed that your calculators are a bit of a pain because any base other than 10 or e isn't really on the calculator. It is now on our graphing calculators, but many calculators still don't have that. So there is actually this change of base formula, and it looks complicated, but once you get it down, it can be quicker to put that into your calculator. So logarithms with any base other than 10 or e can be written in terms of common or natural logarithms using the change of base formula. Change of base formula. This allows you to evaluate any logarithm using a calculator. So yes, your calculator does have that change of base formula. Remember, it's deep in the calculator, it's in your math menu. But we have this kind of fancy formula where you have these bases. So if you want it to be in a base 10, say, so let C be base 10, so you can put it in your calculator. And then you would just type, I'm sorry, not base 10. If this was your original calculator or base that you don't have in your calculator, so say 3. If you typed it instead as base 10 of whatever was originally here, divided by, again, base 10 of then base 3, it actually is equal to the same thing. That sounded confusing, so let's look at an example together. So I want to rewrite and evaluate log base 3 of 8 using both common logarithms and natural logarithms. So I'm going to write this twice. So what the formula says is it says log base 3 of 8 is equal to. So let's kind of piece this apart. This right here is our C, and using our formula, this is our A. So if I want this in the common logarithm, that's log base 10, I would type log, I don't really need to write the base, but it is base 10, of my original A, right, so 8, over log of whatever my original weird base is. So if I type that into my calculator, log of 8 divided by log of my original base, 3, I get that log base 3 of 8 is approximately 1.8928. Really quick, just to verify, remember in your math menu, if you scroll down to A, it's the log base, and you could type this in, and if I type in log base 3 of 8, sure enough, it's 1.8928. Let's test this out for natural logarithms too. So natural logarithm is that log base e. So log base 3 of 8 should be, oops, not log, let's use ln of 8 over ln of our original base, which was 3. ln is on your calculator, it's right under the log button. So ln of 8 divided by ln of 3. And that is also approximately 1.8928. So that's the change of base formula. And that's what your worksheet is over today. Example 5, I went back and forth about including this. I wanted to show you a practical application with logarithms because actually logarithms are in more places than you would expect. The Richter scale is in logarithms. pH scale is actually in logarithms as well. And we use sound intensity in logarithms as well, just because of how sound grows. So I have this example. I don't think I included an example like this on your homework. I can't remember, but if I did, here it is. So for a sound with intensity I in watts per square meter, the loudness, L of I, of the sound in decibels is given by the function L of I equals 10 times log of I over I naught. That I sub 0 is I naught, where I naught is the intensity of a barely audible sound, about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of a track so that the sound's intensity doubles. By how much decibels does the loudness increase? So we want to let I be the original intensity. So then 2i is the doubled intensity. So that lets us then write this. We can say increase in loudness is equal to L of 2i minus L of I. Okay, so that's using this function, but instead of putting I, I'm going to put 2i, right? So when I substitute that in, that will give me, I'm going to substitute this part first. I just write this, except instead of I, I'm going to put 2i. So 10 times log of 2i over I naught. I naught looks weird, but it's just a number. And then this part would be minus 10 log I over I naught. Okay, so these are logarithms. We have a subtraction going on. So if I condensed this, okay, so I substituted here. Let's go ahead and actually first use the distributive property. Remember, the distributive property, you can go backwards with it. So this 10 we could pull out, right, because they both have a 10 attached to them. So I could write this as 10 times log base 2i over, not base, log 2i over I naught minus log I over I naught. If you're not sure about that move, think if you multiply this 10 back in, you get back to that original one. So then I can use the product property. And the reason I can use the product property is this 2 times I up there. So I could write this as 10 times log of 2 plus log of I over I naught minus log of I over I naught. Okay, well maybe you see something. These two are the exact same. And if you subtract something from itself, of course it's just 0. And that still holds true even when we're using logs. So if we simplify this, we would just have 10 times log of 2. So hey, our super complicated thing just got way easier. If you type this into your calculator, you would get 3.01. So we can say the loudness increases by about 3 decibels. So it looks crazy, but using all of these rules, we can totally simplify this.